This is the third video giving logarithm revision examples for A-level students. So I'm not going to redo these introductory slides in detail. You can look at the previous two videos if you want to see these, but just to emphasize that when you answer a question, what we're saying is that you must always write down what you know alongside what is provided in the question. And if you do that, you'll find that the questions are much easier to answer. So the key information you should know, which is in the previous two videos, so you can look at those more slowly. What's the definition of log? Log of 1 is always 0. You need to know the product rule and the quotient rule for logs. You need to know the power rule, and you need to know that if you take the log x of x, you get 1. So look at the previous videos if you want to go through that slide a bit more slowly. And straight on to the questions then. So find, giving your answer to 3 significant figures, the value of x for which this is true. Now, when you get questions like this, you'll notice that they're combining different parts of knowledge. Clearly, it combines quadratics. You can see that this is a quadratic in 4 to the power z. But because you have a power function, it's also making you think, power function, I might need logarithms. So write down what you know. Well, I know this for logarithms, the power rule. And there are other rules we might need, but we'll start with that one. So first of all, it's a quadratic, so let's ask ourselves how we might solve the quadratic. Well, a standard quadratic formula looks like this: ax squared plus bx plus c equals 0, which has roots given by this standard quadratic formula. So let's plug those in. So what I'm going to do is I'm going to let x equal 4 to the z, and that means I end up with 4x squared minus x minus 2 equals 0. Sorry, I didn't have a 4 there, it's just x squared. So x squared minus x minus 2 equals 0. Now if I plug that into the formula, the solution I'm going to get is x equals 1 plus or minus the square root of 1 plus 9, sorry, plus 8, get it right, 1 plus 8, all divided by 2, which gives me 1 plus or minus 3 over 2, which gives me solutions of either 2 or minus 1. So what you've got now is 2 possible solutions. You can have 4 to the power z equals 2, or 4 to the power z equals minus 1. And from this point, you're just going straight into logs. Now, you might want to notice, of course, 4 to the power z equals minus 1 you cannot do, because power functions always give you a positive answer, so you exclude that one. And now you want to do 4 to the power z equals 2. Now, you can do this just by taking logs and writing things like 2 log 4 equals log 2. Sorry, what did I write? Not 2, it should be z. I'm making too many mistakes here. Z log 4 equals log 2, so z equals log 2 over log 4. And you can use whichever log you like. You might, however, notice that you could, by inspection, say here that the solution for z is clearly a half. A similar question, just to make sure that you've got the theme. What if you get something like this? So 2 times 12 to the 2x minus 8 times 12 to the x plus 6 equals 0. Clearly again, this is a quadratic in 12 to the x. And because it's a power function, we think, well, I might need quadratics, and I might also need logarithms. So what am I going to do? Well, first of all, I'm going to write something like z equals 12 to the x, and then this quadratic becomes 2 z squared minus 8z plus 6 equals 0. What we do next then is just plug this into our quadratic formula in order to find the roots. So what we're going to get is the roots for this are z equals 8 plus or minus the square root of 64 minus 48 all divided by 4, which is going to give you 3 or 1. Now you could probably do that one by inspection, but often I would recommend just using the quadratic formula because it's so quick. It often avoids silly mistakes and stops you staring at the paper thinking, oh, can I spot it? Can I spot it? Right, having got that far, what we've got to do now is say that clearly we're trying to solve for 12 to the x equals 1 or 12 to the x equals 3. And we can do this using logs, so this is where the logs come in. So what I can do is I can write things like log of 12 to the x equals log of 3, or x log 12 equals log to the 3, or x equals log 3 over log 12. And if you do that, you'll find that the answer is 0.221. Now, if you go back and say, okay, I've done 12 to the x equals 3, what about 12 to the x equals 1? If you plug that in and go through the procedure, what you'll find is the answer must be x equals 0, because if you want something to a power equals 1, then that power is always 0. But by all means, if you don't believe me, you can go through this log approach and you find you end up with log of 1 in the top, which is 0. Next question then. So find, giving your answer to 3 significant figures, the value for x which satisfies this equation here. And again, we remind you, write down first the log properties you think you might need. Now in this particular case, what I've noticed is there's 2 logs and there's a minus sign in between them. So I'm expecting to use this quotient rule. So let's go ahead and use this quotient rule. So what we've got is log 2 of x plus 1 minus log 2 of x is got to be equal to log 2 of x plus 1 over x, and we've been told that that's equal to log 2 of 5. Now as I've got log 2 on both sides, this now means I've got x plus 1 over x equals 5, or x plus 1 equals 5x. And once you've got that far, did I miss something? No. Then you've now got 1 equals 4x, or x equals 0.25. So you can see that's a relatively straightforward question. Next one then, find, giving your answer to 3 significant figures, the value of x which satisfies this one. And again, you'll see all we need here really is the quotient rule. So I'm going to go direct to it and write that log 4 of 3x plus 1 minus log 4 of x equals log 4 of 3x plus 1 over x. Now on the right hand side we've got 3, and you're saying, oh, that's given me a pain now because I've got 3 on the right hand side and a log 4 on the left hand side. However, if you know your power rule, so we'll put that in here, so it's overlaid, what you'll notice is that 3, you can see I've put it here, is log to the base 4 of 4 cubed. So I can now write log to the base 4 of 3x plus 1 over x is equal to log to the base 4 of 4 cubed, because that equals 3. And of course, having done that, I know 4 cubed is 64, so what I end up with is 3x plus 1 over x equals 64. And now you can simplify that to 3x plus 1 equals 64x, or 1 equals 61x. Next one, again you'll see this is a very similar sort of problem. So what we're going to do is we'll go through straight away and just say, okay, what techniques will we need to use this? We're going to use the product rule because we have a plus here, and because we've got log 4, we're just going to remind ourselves that we might need log 4 of 4 equals 1, or we might need to use things like the power rule on log 4. So first then, we're going to write down using the product rule that log 4 of 6x plus 2 log 4 of x is going to be equal to log 4 of 6x cubed, because obviously 2 log 4 of x is the same as log 4 of x squared, and this is equal to 2. But what you'll notice from what we've written here, that is also equal to log 4 of 4 squared. So now I've got a log 4 on this side and a log 4 on this side, so I can write 6x cubed equals 4 squared equals 16. And therefore x cubed equals 16 over 6. And you should be able to solve that with a standard calculator. Now, a different type of question again. We're trying to add a bit of variety as we go. So given that y equals 3x squared, show the following. Now for this, all I'm really going to need is the product rule. So log 3 of y equals log 3 of 3x squared, because that was the definition of y, it was given as 3x squared, which using this product rule is log 3 of 3 plus log 3 of x squared. Now log 3 of 3 is clearly 1, and log 3 of x squared is clearly 2 log 3 of x. So you'll see that first part is relatively straightforward. It's just saying, do you know your product rule, and do you know your power rule? Next question, it says solve this bit here. Now usually when a question follows like this, you can see there's a link between the two. There's a 1 plus 2 log 3x in part 1 and a 1 plus 2 log 3x in part 2. And so what it's actually asking you to do is go back, and really, they don't always tell you this, it's saying solve, that wasn't meant to be an E, it's actually saying solve log 3 of y equals log 3 of 28x minus 9, which equals log 3 of 3x squared. So there's a bit of subtlety in there. It might not be immediately obvious. It's expecting you to spot that 1 plus 2 log 3 of x is actually just log 3 of 3x squared, and therefore all it's really asking you to do is solve 28x minus 9 equals 3x squared, or if I rearrange this, 3x squared minus 28x plus 9 equals 0. And that, of course, is a standard quadratic. So I'm not going to go through solving the quadratic for you, but if you solve it, you'll find you get roots 9 and a third. Next question then. Here we've got the same sort of problem, and you'll notice a minus in there between the logs, so we think we're going to need the quotient law. We've got log to the base 6, so it's quite possible that we're going to want to do the log 6 rules, things like 3 log 6 of 6 is 3, and so on. So let's make a start on this particular problem. What I'm going to do is first of all write 2 log 6 of 5 minus x minus log 6 of x is going to be equal to log 6. Now because I've got 2 log 6 of 5 minus x, I can write 5 minus x squared, and then I'm dividing by x because of the quotient rule, and that must be equal to 3. But you'll notice what we've written above, that 3 is the same as log 6 of 6 cubed, and so therefore I've got 5 minus x squared over x equals 6 cubed. Having got to that stage, I can write 5 minus x squared equals 216x equals 25 plus x squared minus 10x. And clearly you can now rearrange that into a quadratic and solve it using your quadratic formula. However, we have a warning. Alright, when you solve this using your quadratic formula, please remember that it insists that 0 is less than x is less than 5. Because you'll notice we've got a 5 minus x, so x has to be less than 5, because otherwise you'll get log of a negative number, and we've similarly got log of x, so x has to be greater than 0, or again you'll get log of a negative number. So when you put your answer in, please make sure that you enforce that property.